Welcome. Today, we're diving into Salesforce code quality and coverage. We'll explore what makes code reliable, maintainable, and efficient in the Salesforce environment. Along the way, we'll look at best practices, tools, and strategies to help you write cleaner code and ensure it's thoroughly tested. Let's get started. When we talk about code quality, it's not one size fits all. What counts as high quality for someone building software for cars might look very different to a developer working on a website. Code quality metrics help us separate good code from bad, but the truth is quality depends on context. It changes based on the project, the goals, and even the environment. So, defining code quality means understanding those unique factors that shape what good really means. Good code has a few key traits that keep it solid and reliable. First, it's functional. It does exactly what it's supposed to do, no surprises. Next, it's consistent, following the same style throughout the whole project, which makes it easier to work with. It's also readable, so anyone can jump in and understand or change it without a headache. And finally, it's documented, with clear explanations of the logic and purpose behind it. Bad code, by contrast, is fragile like a Ming vase. It might look impressive from afar, but one wrong move, and it shatters. Maintenance is where software really shows its true cost. Fixing bugs after release is not just tricky, it's far more expensive than catching them early on. For systems where safety matters, this is critical. Plus, we can't predict who will be maintaining the code down the line. So, investing time now to build well pays off huge later. This is the real cost of technical debt, and why it demands our attention. When we talk about quality, there are 6 key pillars that guide us. First, efficiency, making sure our work runs smoothly and uses resources wisely. Then, reliability, delivering consistent results no matter the situation. Readability is next, writing code that's clear and easy to understand. Robustness means handling errors and surprises without breaking down. Maintainability ensures we can update and fix things with ease. Finally, portability, the ability to work across different environments. Together, these pillars build strong, dependable systems. When we talk about Salesforce measurement metrics, we're looking at key ways to keep our code clean and efficient. Code coverage tells us how much of our code is actually tested, aiming for at least 75% before going live. Cyclomatic complexity measures how many different paths our code can take. We want to avoid deep nesting that makes it hard to follow. Abstract interpretation digs into the flow without running the code, catching issues like SOQL queries inside loops. And finally, code duplication reminds us to stick to the dry principle. Don't repeat yourself. Let's talk about 2 powerful tools for static code analysis, PMD and Sonar Quebec. PMD is an open-source detector that helps us catch common programming mistakes in Apex and Visualforce. It spots unused variables, empty catch blocks, and unnecessary object creation. Plus, it fits right into V's code and CI/CD pipelines. Then there's Sonar Quebec, which goes deeper, detecting bugs, vulnerabilities, and what we call code smells. It keeps an eye on quality across all project branches through a centralized dashboard. Together, they help us write cleaner, safer code. Let's talk about advanced scanning tools that help keep Salesforce apps secure. Checkmarks zeroes in on vulnerabilities like SOQL injection and cross-site scripting, offering a specialized ForceCom scanner made with Salesforce. Then there's CodeScan, which takes a broader approach with over 500 rules covering Apex, Lightning Web Components, and metadata. Both tools provide deep, end-to-end analysis tailored specifically for the Salesforce ecosystem, a crucial step in protecting your code from hidden threats. Let's break down the anatomy of a test class in Apex. First, every test class and method needs the @IsTest annotation. This tells the system it's a test. Next, test data has to be created manually. We can't rely on existing org data. To check if our code works, we use assertions like assert_equal to verify results. And most tests run asynchronously in the background so they don't block other processes. These are the essentials of Apex unit testing. When we talk about bulk testing, it's crucial to work with at least 200 records. This helps us stay within governor limits and catch performance issues early. Next, testing under different user contexts is key. Using system run as lets us mimic various security permissions and access levels. Negative testing is just as important. We want to see how the system handles invalid data, making sure exceptions are caught and managed cleanly. Finally, always avoid see all data equals true. Instead, use at test setup to create shared data once per class. These are pro-level testing best practices that keep our code solid. Here's the crucial point. Hitting 75% coverage is just the starting line. Real quality means going beyond that number. We need to cover every use case, positive, negative, and bulk scenarios alike. It's not about chasing a percentage, but about ensuring our solution works reliably in all situations. That's what true deployment readiness looks like. Thank you for joining me today. I hope this talk has sparked some new ideas and inspired you to explore further. Remember, every step forward counts. Stay curious, keep learning, and let's continue this journey together. Until next time.